In this educating video, I want to walk through one of the homework problems from homework number 12. Now, if you don't already have a copy of homework 12, just go ahead and get one from me if you are working on this in class. If you're working on this at home and you don't have a copy, homework 12 is posted in iTunes U. It's posted under, let's see here, week 28, day 1. So you can find homework 12 under week 28, day 1 under the Post tab, or you can go to the Materials tab to pull up Homework 12. Now, I don't want to walk through the first four. If you can see your homework right now, you'll see where it says write the inequality for each statement below, and then there's an A, a B, a C, and a D. I'm going to skip those because I feel like they're fairly easy. If you're having trouble with A, B, C, and D, just raise your hand or send me an email. Let me know that you're still having trouble with those, and I'll help you with those first four inequalities. But let's go ahead and go to one of the harder ones. So number one under answer the following on homework number 12. Now, if you paid attention in class, I gave you sort of like some general guidelines that you can follow to construct inequalities to help you solve certain problems. And the very first guideline says read through the entire problem. Now, I know that seems like common sense, but there's more to this step than you may think. Because what I've noticed with a lot of students is that a lot of students just sort of look through and they kind of get the general idea, but they don't really read the question. When I say read the question, I mean make sure that you understand what this is saying. Okay, so when I say read through the entire problem, I'm really saying check for comprehension. Make sure that you comprehend and that you understand what the problem is telling you and what it's asking for. So let's start with that step. The Rockmart taxi service charges a $1.75 flat rate in addition to $0.65 per mile, so that's 65 cents. Shane has no more than $10 to spend on a ride. Write an inequality that represents Shane's situation. And then B, how many miles can Shane travel without exceeding his limit? So if you just read that and you don't understand what this was telling you, take a minute and reread it again and make sure that you understand it. So basically what this is telling you is it's saying that the Rockmart taxi service, which I have no idea if this is a real place or not, could be, but I don't know if Rockmart's even big enough to have a taxi service. Because you can basically just walk anywhere that you need to go. Anyway, so the Rockmart taxi service, this fictional taxi service, charges a $1.75 flat rate, which means that no matter how far you go, you are going to pay at least a $1.75 flat rate. And then you get charged plus an additional $0.65 or 65 cents per mile added to that. Okay? Now, there's a problem here because we're limited to how far we can go, because Shane only has $10 to spend. So we got to figure out an inequality that will allow us to figure out how many miles can Shane travel without exceeding his limit. So number 2 says, before we start constructing our inequality, we need to underline or circle the important information and keywords that you need to solve the problem. Now, is this guideline necessary? Absolutely not. It's just to help some of you, if you're having trouble understanding these questions, it's to help you figure out what symbols and what needs to be added to what needs to be multiplied by to what, and if you do this step, it'll help you construct these inequalities. So let's start here. Underline or circle the important information and keywords that you need to solve the problem. What do you think? What do you think are the keywords in this question? Yeah, I'd probably say that the keywords, now I'm going to do 2 different colors here. I'm going to do red for the numbers that I'm going to use, and then I'm going to use, so I'll use red for the numbers. So we know that there's a $1.75 flat rate. And then I'll use yellow, and I'll underline the words that I think are telling me what sort of operation or what kind of symbol that I need to use. So we know we've got a $1.75 flat rate. In addition, that means I'm going to add. So in addition, that's sort of hinting at that we're going to add something to $0.65 per mile. So I'll circle that. That's another number, another quantity. And then Shane has no more than $10 to spend on a ride. Now, you may just be tempted to go straight to the $10 here, But don't forget about this no more than. That's an important key word here. That's telling me what symbol that I'm going to use. No more than. And we'll see what symbol that we're going to use for no more than in just a second. And then we've got $10 to spend. So those are my key words. We can also highlight the keywords in our actual questions, A and B. Write the inequality that represents Shane's situation. There's not really anything there. But B, how many miles? How many miles? So I'll put how many miles, I'll just say many miles, can Shane travel without exceeding his limit? So there is a limit here. There's always going to be a limit when we're talking about inequalities. So we've successfully underlined or circled the important information and keywords that you need to solve the problem. Now we need to identify and define our variables. Okay, so in this case, this $1.75, that's going to be a constant. This 0.65, that's also going to be a constant, probably a constant factor here. The in addition, that's an operation, not a variable. No more than, that's also telling me what symbol I need to use. $10, another constant here. But then we say, how many miles can Shane travel without exceeding his limit? So this is something that we don't know. This is something that we want to know. So identify and define our variables. We know that our variable in this case is going to be m, which you can use really anything you want. I just use m for miles, but you could call it x if you wanted to. You could call it d. You could draw a little cheeseburger. It doesn't matter what kind of symbol that you want to use. I'm just going to use m for miles. So this is my variable, and I have defined my variable. I'm saying m is miles. So with the 3 lines here, that's defining m as miles. Okay, m is miles. Now we go on to probably the hardest part of this entire process, and that is writing the equation or the inequality here. So you basically, the best way to do it is to go back to your keywords, look at your keywords, and look at your numbers. So start by writing the first number. That's a good place to start. So what is the first number that's given? $1.75 flat rate. So what I do here is I'm just going to write $1.75 flat rate. So there's $1.75 flat rate. And what does it say? In addition, so $1.75 flat rate, in addition, so that means I'm going to be adding something in addition to 0.65 per mile. So in addition to, that's telling me that I need to add here. So I'm adding, but adding what? In addition to this 0.65 per mile. So this is going to be how much extra we're going to have to pay, and it's going to be dependent upon the number of miles that we travel. So I say plus 0.65 dollars per mile, or 65 cents per mile. Now, you tell me, what needs to be added here? What needs to be added here, or here, or here? There's something that needs to be added. I'll go ahead and tell you. It's our variable m needs to be added somewhere, or really added, I shouldn't say added, included somewhere in this expression. Where do you think I should put that in? Yeah, so hopefully you were able to say that this is a flat rate. So $1.75 is a flat rate, but the 0.65, the second term, it's going to determine how much we're going to pay per mile. So we need to add that m here. So what is this telling me? It's telling me that I have to pay $1.75 flat rate. So just basically for me getting into the cab, I have to pay this $1.75. But then I have to pay $0.65 per every mile. So if I travel 2 miles, I'll be paying $1.75 plus 2 times 0.65. If I travel 3 miles, I'm going to pay $1.75 plus 3 times 0.65. I hope that sort of makes sense to you at this point. Now this is where the inequality comes into play. So we finished this part of our statement, but then it says that Shane has no more than $10 to spend. Okay, so let's just go ahead and say that we know that there's going to be something that goes here, a symbol that goes right here, and we're going to say that there's $10 on the other side. Okay, because this is all that Shane has. This is all the money that Shane has. on this side of the inequality or the equation. We don't know where we're headed with this yet. Well, I already tell you it's an inequality, so we've got this inequality. But if Shane only has $10, then I know that all of this side, which is going to be what Shane has to pay, right? Because if we have $1.75 that he has to pay plus $0.65 for every mile that he travels, all of this, okay, this entire quantity, which I'll group in blue, this entire quantity has to be less than, the amount of money that Shane has. Because if this is more than $10, then Shane cannot afford to pay for this. And then he's going to get arrested and go to jail. And who knows what else happens in jail. I don't want to know what happens in jail. I've never been in jail, and I don't want Shane to go to jail. So here, we want to make sure that on the left side of the equation, that this entire quantity is less than how much money Shane has to spend. But remember, Shane has $10. Shane has $10, so this could equal $10 as well. And we denote that by just putting a little line right here. So what this symbol is saying is that this entire quantity has to be less than or equal to $10. Now, at this point, we want to go on to the next guideline, which is to solve this inequality, which is very, very straightforward. You use the exact same rules that you use if this were just an equal sign here. So we put in $1.75 plus 0.65 times m less than or equal to $10. So the first thing that I want to do is I want to subtract $1.75 from both sides. Subtract $1.75, and I get 0.65 m is less than or equal to, let's see here, 8. So yeah, 10. We get to 10 minus $1.75. That's going to be 8.25, which we're getting a little cramp there. 8.25. And now I need to solve for my m, because remember, the goal of this is to figure out how many miles can Shane travel without exceeding his limit. How many miles can he travel without exceeding his limit? That's what this is telling me. It's going to tell me how many miles Shane can travel without exceeding this limit of $10. Now, the last step, I just divide both sides by 0.65. Divide by 0.65. And we find that m has to be less than or equal to 12.69 miles. Now, where did that come from? This 12.69, if you just type in 8.25 divided by 0.65, that will give you your 12.69. And we just put that into a box and we say that's our answer. I mean, wasn't that fantastic? I mean, that was pretty cool how we were able to see the inequality. Or use an inequality to figure out how far we can travel without exceeding our $10. I mean, that's so exciting that, I mean, I'm almost as happy as this little baby right here. So let's recap. So what did we do here? So to solve for this 0.65 m, we divided both sides by 0.65, and that meant that my 0.65 canceled here, and my $0.65 canceled there, and then I was just left with this m. That's where this m came from, and divided these two to get this. So this is telling me that I can travel, or that Shane can travel, 12.69 miles. So that means m has to be less than or equal to 12.69 miles to make sure that we do not exceed his $10 that he has to spend on his ride. Now, your last task. I'm not going to walk you through this one, but I want you to try it on your own. Write your answer in a complete sentence. Write it in that blank on your homework assignment. And if you're in class right now, write it down and have me check it before you leave today. All right, thanks, guys. Hope you enjoyed this lesson. And if you have any questions, just let me know.